Hello, everyone. Welcome to today's tech talk about SSO for Kubernetes using DEX. It's a CNCF project, and it's actually a federated OpenID Connect provider. And what this exactly means is what we're going to learn today. Before we get into the topic, who am I? My name is Martin Nirtl. I am a solution architect here at Mirantis. If you want to follow me on social media, LinkedIn, or GitHub, these are my handles, and you can find me there. Give me a follow, reach out to me, whatever you like. So what's on the agenda for today? We will start with a short SSO recap. So what does single sign-on actually mean? What's the flow? And then we will move towards SSO for Kubernetes. Why is it maybe useful there? Why is it important? What do we gain? And yeah, with that, of course, we will use DEX, because DEX will enable us to provide single sign-on for our Kubernetes cluster. That's the main topic of today. And when we are done with that, we go towards beyond authentication. So when we are done with SSO, what's next, right? We maybe also want to consider authorization. Last topic of today is a hands-on demo. So we're going to deploy DEX in a cluster. We will configure it appropriately, and then we will also play with it in order to see how the authentication flow then works and how it integrates with the plain Kubernetes authorization mechanisms like RBAC.
Need to learn Kubernetes quickly? Check out our free ebook with hands-on exercises you can complete on your laptop over a short break or lunch. Visit mirantis.com/learnkates to download now.
Okay, let's do a short recap on single sign-on. So in the middle, you can see the user who, for example, wants to interact with any website. In our case, on the left, this would be a service provider, could be, for example, a Kubernetes cluster, right? So the user tries to access the service provider in a way. Typically, when we talk about web applications, this would be in the browser. For SSO, we would, when we try to authenticate, be redirected towards the identity provider. And there we would either log in, or if there is a cookie available which already tells the identity provider that we are logged in already, we would just get back to our application. In case, of course, there is no cookie available, we would need to put in our credentials, maybe also two-factor authentication is being asked, and then we would get logged in. Optionally, then also this, as mentioned, cookie can be stored in the browser or somewhere else in order to tell the identity provider for later that you are already not identified, but authenticated. And yeah, once you're logged in, you get redirected back to your service provider with the token attached, and then you can authenticate also at the web application with that given token. Typically, the token is then also stored for this web application, for example, in a session cookie or in a cookie. And from then on, every subsequent call is being authenticated, and you can use your application with your personal user. Guess that's pretty straightforward. We use SSO every day, so I hope that's clear. If there are any questions around it, please put it in the Q&A feature. Okay, moving towards Kubernetes now. Why single sign-on for Kubernetes? Well, actually, the answer hides in the second bullet point already. Why certificate-based authentication not good enough? So by default, as everybody knows, you get certificate-based authentication for your Kubernetes cluster. These certificates are long-living and they cannot be revoked, unfortunately. So when you have it, you have access to the cluster. Not are they a security threat for your cluster with this long-living attribute. You also have the problem of managing them, because these are files, right? They are hard to manage, not only for you as the operator maybe, but also for the person like interacting with the cluster, like a developer or a DevOps person. So they need to take care of these. Typically, like, of course, this is now in a kubeconfig file, but still not easy to overlook if you have, let's say, 20 or more clusters to interact with. And also they're easy to lose. I mean, it's relatively simple to forget where you put that kube file, that kubeconfig file. And once you, I don't know, have an exploit on your machine or on a VM, those keys get lost, and then they have unprivileged access maybe to your cluster in case this is, for example, having an admin role assigned to that certificate. And going away from this really decentral approach of having those certificates that could fly around anywhere, we can also adopt something more meaningful, something more central, which is in fact single sign-on. And with the possibility of different Kubernetes authentication strategies, we can not only have client certs, but to the rescue, we also have OIDC tokens. This stands for OpenID Connect and is also kind of a mechanism to implement SSO. I won't go into detail too much on OIDC today. Hope that's good enough. You will understand the concepts, and if you're curious to learn more about it, please also put it in chat, and we can do another presentation on that in more detail. Apart from the two client certs, OIDC tokens, there are also more authentication strategies in Kubernetes, like static tokens and others. Please, I will share the link to the presentation later on, and you can then follow also the links to the websites that I have linked here. So we've talked about SSO in the context of Kubernetes. What's next? Let's talk about the enabler. How do we get there? And here, DEX enters the game. DEX is, as said, a SysF project in sandbox state. It is a federated OIDC provider. What this means is maybe what we'll see later in the demo, so this becomes more tangible. It is able to integrate identity providers, lots of them. Actually, we see a list on the right. This is from the DEX website. You can see you have GitHub here, SAML 2.0, pretty generic, but also GitLab, Google, LinkedIn, Microsoft, many, many more. You also have like the support matrix from it. I just put this here in case you're curious on what are the providers that are supported by DEX. And hence, it's really a provider to rule them all, because you can make Kubernetes integrate with DEX, and from DEX on, you can then again connect to your identity provider. So it's actually also relatively easy to exchange them, and you only need to deploy DEX once. And that's why it's really easy. And once you understand how to deploy it properly, it's a great tool. But now we just know that what DEX is and how it integrates other identity providers, like, for example, Microsoft AD. How does it work with Kubernetes? Well, in Kubernetes, there is a tool which is called Kubelogin, and this can also be installed with Crew, the plugin manager for kubectl. So you can then use Kubelogin for the OIDC login flow. We will come to that later, because I will show this in my demo then as well, how to actually set this up and how to utilize it, how to use it. Coming to the last point, which I will only briefly touch, we will also touch then later in the demo how to actually assign roles to our OIDC user. But also I wanted to raise the topic that authentication is not the end, it's actually the beginning, but it's an important aspect of it. So authentication is actually identifying my user. It's all about knowing who is calling, versus authorization, auth-set, often abbreviated, is all about what is the user allowed to do. Now, bringing those together, authentication and authorization, they are easily manageable when they are kept central. Meaning, when you have SSO, you can overlook who are my users, you can manage them, put them in groups, for example. That's where you want to go, typically. Except you want to have a hard life, I guess. Also, authorization. It doesn't make much sense if you have in every cluster different roles for different users. You enter configuration hell, let's call it, and you will hardly find a pattern that will work for you in the long term. So I tell you, like, try to really establish a central approach in managing your users, but also your authorization means, and you will be successful in the long term and having a really good also security posture, right? You don't want to give your users too many privileges, because this comes always with a risk. The more privileges, the more risk. And yeah, therefore, I've also added here a short list of tools that you maybe want to use or have a look, which help you to stay on top of that. For example, Fairwind's RBAC Manager is really nice. How to bring all those roles and bindings to your cluster, because as you know, roles and bindings are namespaced in Kubernetes, and you can have nice namespace selector kind of things to bring your roles and bindings to each and every namespace in a cluster. So this scales a little bit more when you want to apply those to your clusters. Audit to RBAC is a fancy project if you don't have any idea what actually you need to put into the permissions. Well, this can help you to create the role from audit logs. So you use you take a user, you do whatever you think a certain role, like a DevOps engineer does with a cluster, and then you just pull the audit logs into the tool, and it will automatically come up with the right role for that user. Pretty neat, I would say, if you need a starting point. And the last two, Parallels and Teleport. Parallels is free and open source. It claims to offer zero trust Kubernetes with zero friction. Also, I must say I have not used it, but it looks promising. I thought it's worth putting it on the list and making you aware of the tool. So please check it out. And for the last one, Teleport, I'm not sure whether this is open source, but it definitely has a free version of it, so you can use it. Some features are behind a paywall, but Teleport is great for accessing your infrastructure, no matter if it's Kubernetes clusters, web applications, VMs. Awesome tool. Also, if you're looking for better authorization, authentication platforms, like that's also a perfect solution, and I really recommend to check this out. And with that, I hope that wasn't too long. Theoretical part is over. Let's get authenticated. And let's have a look what I've prepared for today's demo. And then we can also get started with some hands-on experience on command line and whatever else. So what I have prepared today is the following. We will use AWS infrastructure, which is not on this map here, on this architecture diagram. So we have two Kubernetes clusters actually for the demo, and for simplicity reasons, I only use one today, but this should give you also a conceptual understanding on how you can roll this out at scale. So what do we have? Let's first talk about infrastructure. As said, we have a cluster which runs obviously Kube API. It runs in every cluster typically, and we also have DEX installed in a Kubernetes cluster. Now, in order to make DEX work and let my users interact with it, it doesn't really matter whether DEX is installed immediately or later on. It will still work. So in case you feel like there could be some kind of race condition, not really. Only thing is that you cannot use OIDC until you have the OIDC mechanism for authentication with Kubernetes until it's running. So what else do we have here? We have a connector. Our identity provider for the demo will be Microsoft AD, or as it's called nowadays, Microsoft Entra ID. When I prepared the demo initially, it was still called Azure ID. So today I prepared the demo, and I was pretty surprised that they changed the name. I got so much used to the ID that now I feel a little bit sad about it. But Microsoft for sure had good reasons for doing that. Okay, apart from naming things, how does it look? And once we have the DEX running and configured our cluster being the OIDC issuer for the token for the user to interact with it, we will see also how this really looks later when we do the setup for our user. We can have some flows, right? So how does the typical Martin, like myself, interact with a cluster? Initially, we will typically do a setup or a login. Setup is because Kubelogin, the tool we are using in order to utilize the OIDC feature, the OIDC authentication, we do a setup there, which is then kind of a streamlined and very well guided approach on setting this up locally. You will love it. Also, once we run that, we talk to DEX directly. So we don't talk to the Kubernetes cluster initially, we talk to DEX. Once we talk to DEX, we get actually forwarded to our authentication, to our identity provider, which is Microsoft AD. We will log in there, put our credentials, maybe two-factor authentication, and then we get a token back. And with that token, we can then talk to our Kube API cluster, for example. And the Kube API cluster here also has the same issuer or IDC issuer configured. And so it knows, okay, I got this OIDC token from Martin. I should verify it, right? I should validate whether this is actually something that is valid. And how does it do it? It talks to DEX. So important thing, I, as a person who wants to talk to the Kube API, need to be able to access DEX. Also, the cluster, so the Kube API server, needs to be able to talk to DEX in order to validate the tokens. Once DEX validates the token, or actually not DEX validates it, but Kube API server asks for information, which could be, for example, a public key, to validate the token locally here. And once it's validated successfully, it says, well, great. It will check also authorization. For example, if I do a kubectl get nodes, it checks whether I'm allowed to do this. And when I'm also allowed to do or to query the nodes, it will tell me like what nodes are in my cluster. So that's the flow. Very simple 6 steps. If you have or if you are interested in how this really deeply looks, we can also check this out after the demo, because I've prepared also a flowchart there. Just let me know in the Q&A feature, please, and we can have a look on that later. Now, coming to the setup and useful links, you can find all the talk assets from tomorrow, not today. So I will load them up to GitHub after this talk. Under https.com, github.com, Martin Nirtl /talks. The slides are there, the Terraform files for the AWS infra, K0s configuration, as we use K0s today. If you don't know K0s, awesome Kubernetes distribution, single binary, really easy to maintain and install. You should definitely check it out. We will also check out the configuration file today, so you will get a glimpse of what this is actually about. Apart from that, we will also check out the Kubernetes manifest. We see some some fancy customization there. So if you don't got your hands on customization, it's actually a way on how to customize Kubernetes manifests. I love it, but I also love Helm. So, I'm in both camps. Guess if there are camps, I don't know. And last but not least, there will also be a step-by-step demo guide so that you can also replicate this for you on your environment, in your environment. Also, I've put some links to documentation, which I thought they are useful. So please check them out. And yeah, now let's switch over to the demo. So I'm now on my VS Code. We have all the files in here. This is actually what I will upload tomorrow. So no spoiler, I minimize everything. Let's get this started. I'm now connected with a certificate-based approach to my cluster and have admin privileges there. To show who am I have this who am I plugin installed with Crew. It tells me I'm a Kubernetes admin. Also on the right, if you want to maybe follow along and make sure that I'm not lying to you or tell you something, which is not true, you always will see here my user and the cluster name. At the moment, it's labs.dex, and the context name is also labs.dex. So what do we do next? Check out how many nodes do we have. By the way, I'm using a plugin for OMI/SSH, which is called kubectl, obviously, and this allows me to use really fancy abbreviations when interacting with kubectl. So it says KGNO, kubectl get nodes, just in short. So if you want to level up your game on the command line, that would be perfect start. Cool. Having done that, we can also quickly check what's running there. kubectl get pods and check all the pods. I've not much installed, just some utilities like Cert Manager and an Ingress Nginx, which allows us then to get also publicly available public access to our DEX, but also with Cert Manager in combination HTTP challenges for ACME, so we get certificates that are signed and provided by Let's Encrypt. And with that, let's check out how does actually the Kubernetes cluster look like, because we need to configure our Kubernetes cluster, and we can do it in advance, as I mentioned earlier, in order to provide the OIDC issuer capabilities. So this is the file for configuring K0s, the whole cluster, the control plane, including the workers, it has a touch of Ansible playbooks or Ansible inventory, actually, which is like these are our nodes, right? And we won't go into detail as much. I've had the link to the documentation in my slides. So we will actually focus on the extra arc section for our control plane. And everything that you need to know for today and what is important for today is actually starting with OIDC. What we provide here is exactly the connecting part to DEX for validating a token once a user comes and talks to the Kube API. So what do we provide? So we say, okay, the OIDC client ID, which is actually Kubernetes, so DEX knows what client is calling in. This will become more clear when I show you later also the DEX configuration once we deploy DEX, but slowly, step by step. The OIDC issue URL will tell DEX, or will tell, the Kube API where to find DEX and where to find those keys for validating whether the token is true or not true, but valid or not. Also, we will find the OIDC user claim, so we know, okay, what information in the token is important for my user. What is the identification that my Kube API should use for identifying the user? And the field is called email. So email should be part of the token that we get from our identity provider. Cool enough. So that's the KCRS config. In order to prove also quickly, this is my kube config. So you can really see here on the bottom that I'm the admin. I'm using client-based authentication at the moment, which is, as said, hard to maintain, easy to lose. So we want to change that. But before we can do this, and remember I said we don't have yet now DEX running, but we also need to have an identity provider that has our users configured. So let's check this out quickly. I have prepared this already in Azure AD or Entra ID. It's called nowadays. Again, I really need to get used to this. Let's switch over to Microsoft. So I'm here in my personal subscription from Azure, and we find Microsoft Entra ID here, for example, and here it's what is important. Well, enterprise applications is important because this allows me to manage, for example, my DEX application, which I've already created, but also it allows me to manage like what users should have access to it, so I can assign the users to that application. So this is the application. When we click on users and groups, we also find the user. Here you see Martin Nirtl, like this, that's me, that's my user, is attached. Unfortunately, I cannot use groups in order to really show the scale of this because my personal subscription doesn't let me do that. But fortunately, at least I can assign myself to a group so that later on when we get the ID token from Azure, we will see also that there is a groups claim so that I don't need to, come up with the role bindings for each individual user, but I can also utilize the groups to assign certain permissions to my users, to my group, and then utilize it in a more scaling way, right? So that's Kubernetes administrators. That will be our prime example today. I will also prove by revoking the permissions that this is really being used, by the way. So that's how you assign people and to the application. In this case, DEX IDP. You can also call it Kubernetes if you want. It really doesn't matter what you name, what name you apply to it. And also what we need to do is we need to check actually, and this is again an Entra ID thing, the registrations, the application registrations. Now quickly app registrations. Here we also find DEX IDP, and this is important now for hooking this up with DEX, because this is simply how the authentication flow works. You need to have a callback API that you need to specify here. So when you are doing the authentication, the identity provider, in this case Azure AD, is also able to send you back to the right place. Sorry, authentication. And this is exactly the redirect URI. Here we see already it's DEX, apps, labs, DEX, Mirantis, like my cluster address, URL, /callback. Once we've installed it, we can also check whether it's really running there by visiting that URL. So just remember, maybe labs -tags. The rest is maybe more irrelevant. The first part is just telling you the tags application. That's how it works. Cool. Also important, because we don't want to let everybody like talk to our Azure ID. So you maybe want to have certificates and secrets, and in that case a secret. So we need to provide tags with a secret in order to talk to our ID, to our Active Directory. And this is what we have here. We will also find that information then in clear text. So please don't hack me today. I will clear this anyway tomorrow, so you won't really have a chance to exploit this, but still. So these are the keys that we also need to use in order to let text talk to our tenants. I'm now talking about Azure AD tenant, and see what users are there when somebody wants to authenticate. Having shown that, we can now actually head on and deploy tags. So let's get back to VS Code and check out the manifest files. So I said it's everything big customization. So when you want to check this out, please feel free. I will also include some other things like tutorials around customize. So if you don't know customize, you can also still use this and utilize it. Because I know when you're not coming from the customize world, it's sometimes hard to understand. And I personally always felt like documentation is not as good on the tool as it could be. So yeah, I've prepared everything actually in the config. So that's the important part. If you also feel like we should focus more on it, please again put in a question in the Q&A and we can focus on any aspect that maybe interests you. Quickly, what do we have here apart from the core configuration for our tags deployment? We have a certificate for Cert Manager in order to retrieve the certificate for HTTPS from Let's Encrypt. We have the ingress part, which tells Nginx where to send our traffic to, coming in via text.apps.labs-tags and so on. And we also have, as said, our configuration, which is the last part of the custom stuff around tags. Here we find the issue URL. You need to tell it tags as well. The storage, in that case, this is not an HA deployment. So please, if you want to do something more production grade, like consider PostgreSQL, maybe with some kind of operator like the one from Zalando or Crunchy Data, I think it's called, like use them. They are nice for managing data on Kubernetes, in that case, Postgres, and you will have an HA setup out of the box. Also, this is the information then for the web. So where my interface is listening, in that case, port 5554. And here comes really the important part, connectors. As said, we use Microsoft today. Here we have tenant information, which is my tenant, but it's not really important. The important parts, because you can put anything here, the important parts come here. These are the client secret and the client ID, which I mentioned earlier, like which you can, of course, now take and use, but only for the next half an hour. So this actually tells tags how to talk to my Azure ID. We also have the redirect URI, so it knows once authenticated, like where to send it. Tenant information, which identifies my Azure ID subscription actually, or tenant, because in a subscription you can have multiple tenants in Azure. And also how to maybe transform the email, right? So I want to have it lowercase, and so it's kind of normalized. You can also do some whitelisting and pre-filtering of the groups if you have many groups, because that's also a problem if you work in a huge enterprise. Potentially you have like hundreds of groups you're assigned to. And I think there is actually a limit that you can retrieve from Azure ID, for example. And if you know, well, like most of the groups don't make sense in the Kubernetes context, this is a really nice feature because you can actually whitelist which groups should be queried for the claim. And that's really a neat feature. At least that's why I left it in here to highlight this to you as well. So that's the part for tags making the call to Azure AD. And now we also need to create the part to have some authentication also for our Kube APIs. So this configuration, it's actually single, is for our Kubernetes APIs. And we will apply the same secret everywhere, but of course we could do, for example, a different secret for every Kubernetes cluster. So this is really a static secret that our cluster also has, or actually we as a user, because when we talk to DEX, we come via kubectl, and we will provide exactly that secret that we specify here. This was really confusing for me initially. So this is really like you set up a static password for the kubectl Kubelogin plugin, and you use this when you authenticate yourself against it. This is really important. So this is not like you provide a secret and then DEX does use it as a static client or something. So don't get confused there. Also, redirect URIs, very confusing as well. Why localhost 8000? Come on my host, nothing is running on localhost 8000. Well, also kind of tricky, but also easy when you know it. Kubelogin, so this plugin that we will use with kubectl, actually creates and opens support on port 8000 once you start the setup process or the login process, and the final landing, the final redirect will be here on localhost 8000, which is how kubectl also is able then to retrieve the token and put it in its storage, let's call it. Like right in the browser we have cookies, in on the shell we need to have something else. Cool. So that's the configuration. As said again, call for questions. If you want to talk about anything later, please feel free to put the question into the Q&A. And with that said, let's now deploy it. Again, let's switch to the command line. And now I need to get focused because talking is simpler than applying things. So let's go into demo and I think manifest and text demo. Yes, okay. And here we can do K apply. You maybe know -F for file, but -K lets me do customization directly. And I will now apply the things. It will give us a nice list of what is actually being created. And here we can now see that, for example, namespace DEX IDP is created and some other stuff. We can also check now the ports in that namespace. So, for example, in the namespace of not Crossplane, but of DEX. And here we see already like two ports. One is waiting, the DEX. Why? Because it's actually waiting for the certificates that it can use them for hosting the HTTPS. Also, we see the CM ACME HTTP solver, which is performing the ACME challenge. When we do this again, like we see, for example, that the ACME challenge is done, which means that when we query, for example, now, let me put this into the middle. When we now query, for example, for the certificate in the DEX namespace, we see also that the DEX certificate is already here. We've read it through. So it means the ACME challenge was successfully performed, and we should see already something when we visit our DEX deployment. Cool. So DEX is available, yet we don't know whether it's really working. So let's quickly check the logs as well. Okay. So we see that we are listening on the interfaces. Let's not now go deeper on these logs. I see them the first time today, so we won't touch them. But we see like what we've configured. For example, we have static client, which is called Kubernetes. We will also see somewhere the information that we have the IDP of Azure in use. So that's cool. And with that said, we now check out what we get from the DEX deployment. So let's visit quickly the browser again. Back in the browser, let's switch to the next tab. I've already opened this, and here you will see that we are now on DEX, apps, labs, DEX, Mirantis. So exactly the route, the URL of our DEX deployment. And we go to the path well-known OpenID configuration, which stands for OpenID. Open at OIDC, right? OpenID connect is missing, and we see here the configuration. And here, I want to just show you, this is actually where, for example, Kubernetes API is able to, where Kubernetes API will land and will look like what information is here. And it will actually check for the JSON web key stuff. I don't know what the S stands for. Key set, I think. JSON web token key. Yeah, that's it. And that's the URL to it. And let's quickly check also what this gives us, because that's maybe interesting to you as well. So this gives us also an array of keys, which we then can use and use for validate whether the OIDC token that the user comes with and tries to authenticate against our Kubernetes API, we can use the payload here to validate whether the token is a valid one and whether it's really signed by our DEX, because DEX will provide us with the token, not Azure AD, but more to that later. And now we can already, because DEX is running, right, we also check the Azure AD. What's important here again, that you have to really put in the web redirect URI in order to make this work. Otherwise, you would get an error when you do the authentication for the first time, or every time actually. So now let's switch back again to the bash, to the shell, and see what we get back in VS Code. So let's quickly check what I've installed here. I have many plugins installed, as said, but also I've installed the Kubelogin. It's called OIDC login when you install it, I think, via Crew, and it's here. I have many of them installed. So if you're curious where to find this in the web, it's int 128 Kubelogin. Now don't get confused. There's also one from Azure, which is Azure specific. But here you will find also the different ways on how to install this. I've installed it via Crew, but you can also install it via Brew or Coco, whatever platform you are on. I think there are multiple means actually to install this, multiple ways. So what we need to run now is literally the thing that I mentioned earlier. I will show you the demo flow again quickly. So we do now the first step, the setup and the login. And why, now you will understand why I call this actually setup, because the Kubelogin plugin actually provides a really nice way to understand what's happening. And also it instructs us and gives us a guide on how to set this up properly, this OIDC thing. And typically you only do this once, right? Because you have this central DEX instance that talks to your IDP, your identity provider being, for example, Azure. And then it's done. Not game over, hopefully, but you have a running setup, and then then you're all good. That's the point of central authentication. So with that, we do now the setup. And the setup, I've also put the file in here so you have easier times in order to run the command. This is the command that we are going to run. It's kubectl OIDC login setup. This is how Crew plugins work. They just add subcommands that you didn't have before. So don't get confused if you don't have it. You don't have the plugin installed. And here you will see what information we can attach. Very similar to Kube API, we have the issue URL, the client ID, the scope. But what we don't have at the Kubernetes API is the OIDC client secret. Why? The Kube API doesn't need the secret, because it will just ask for this JWKS for the JSON web token key set in order to validate the token. Everything for the validation is happening without any need for authenticating against DEX. This is public information. There can't be any harm by that. But if we want to log in, we can kind of whitelist the people that are allowed to talk to our DEX instance, to authenticate against our DEX instance. And we have the secret here, which is actually the secret that I've shown earlier in the config. So exactly the secret here from static clients. Cool. And with that, let's now run this command and see what we get. Now you see authentication in progress. That is not what I see. It is on my machine. I see now the browser already the browser opened itself. It opened the window. And let me quickly open this for you. So this is what I got. What we missed is I'm already authenticated against Azure. Sorry for that. We are here already on the DEX page again. So here I can now also grant Kubernetes. As you see, this is the client. The following information: basic profile information, your email address, and the groups. These are the claims that we did. Here we can now grant access. And with that, we see that we are now, what I told you earlier, redirected to localhost. So how does it work? We first land for the authentication on the IDP provider, which is Azure. We enter our credentials. We get the token from Azure and get sent back redirected to Dex. Dex gets the token, sees everything because the tokens actually are clear text, so it sees the claims, the username, everything inside, and it will then give us another token in exchange, which it sends here on localhost 8000. So this is how kubectl retrieves the token that Dex will then validate, if that makes sense. We also, if this is not clear, please let me know in the Q&A and we can have a look on the authentication flow. Maybe we'll have a look anyway. Okay, and let's now really quickly jump back because we're running out of time anyway. So let's go back to the command line. And here we see authentication in progress. This is where we went to the browser, and now we see we come back and we got the token with lots of claims. We see the issuer. Most importantly, we see the groups that I've shown you earlier. So I got also this information, Kubernetes administrators, and the email, right, which has some other information attached to it because it's an external provider. As said, this is also very guided, which I really like about the command, and the command which we ran was OIDC login setup. It provides us also with the first steps, like to bind a cluster role, for example, but also how to, if you didn't configure your cluster yet, how to configure it properly. And this is actually what we need to execute, this command, in order to bring the user authentication stuff to our kubectl, to our kubeconfig file. So let's run that quickly. And when we now check, for example, our kubeconfig, we will see here on the bottom that this is here. So this is kind of dynamic authentication with via exec, and it runs OIDC login get token via our Dex instance. And now we really need to change the user that we use, because don't forget, we are still using at the moment the certificate-based authentication. So I can do anything here. So in that terms, kubectl get nodes. Before we switch now the user, let's provide our OIDC user also with the right administrator privileges, so we can, for example, do something with the cluster. So let's quickly do this. And I've prepared already the command. So we create a cluster role binding here, and we assign it to the group Kubernetes administrators. If you remember, like this was the group that was assigned to my user in Azure AD. And we call the cluster role binding Dex admins. We bind it to the cluster role cluster admin, so that's the admin role that is natively and typically there in Kubernetes. And with that done, we can now switch to our OIDC user and check whether we maybe can now interact with the cluster as well. So we do config, set the user to OIDC. On the right, we see that the user changed. And if I now do Kubernetes get nodes, for example, you don't see this, but I will show this again because I have selected that I should not stay logged in. So I get asked always when the token expires to re-authenticate via the browser. So here again, now this is triggered from my kubectl get token command, the kubectl OIDC login get token command. I grant access. Okay, authenticated. I switch back to the command line, and here I already see the get nodes. I will do this quickly again, so you see it get nodes, and voila, it's done. If I do now who am I, and this is also a Crew plugin which tells me who am I, you see exactly my email from before. And now, most importantly, I will prove to you that I'm really a different user by deleting the cluster role binding, which is possible because I'm an admin. But after that, I won't have access to the cluster anymore in the way I had before. I won't be an admin. I actually will be nothing. Okay, so let's delete it. Delete cluster role binding, and done. And if I now do query for the nodes again, it will tell me, like, look, the user, Martin Nirtl at Gmail, whatever, is not eligible or not allowed to list resources in the Nodes API group. And this proves like how this works. So that was the demo to keep it short now, really. So I hope it was clear, and I will also share those resources with you. Now, coming back to the slides quickly to really wrap this up. Yeah, well, we are authenticated. I hope you liked the session and the demo. And with that, let's really quickly have a look on the Kube login flow so that you get also a more deep understanding of it. So what in fact happens when you run this login is that first Kubelogin will ask to, like, opens the browser. It will send an authentication request to your identity provider. You will also authenticate there. You will get a response back. And then later on also an authentication response. Remember, I told you what really happens under the hood is you first land on Azure AD where you put your credentials. You get redirected to DEX so that DEX is getting the Azure ID token where it sees all the information. And then DEX provides you with its own token, like published, not published, but created by DEX, and hands it over to localhost 8000 so that your kubectl plugin or IDC login can also retrieve it from there and later on use it when interacting against the Kube API server. So we are step 7. We go back. Like this is exactly token request, token response, what's happening when DEX does provide you with the token. And then you get token to kubectl, you store it locally, and then you can request the Kube API server for whatever information. Let's say query for the nodes. What Kube API server does, it asks for the JWKS payload. It gets it back. It uses this payload for validating the token. And then if also authorization is fulfilled and you have the rights to see the nodes, you will get the node list returned. And finally, you can also see it on the screen. So that's the Kube login flow. This is also available, like this is personally, I felt like this was really the best diagram that I've seen when I did the research for this. So you will find this on the Kube login on GitHub. So check this out. They also have some videos there, neat information, really great. And yeah, with that, that's really now the end of this presentation today. What's coming next? So first of all, I want to thank you for attending this call. I hope you really liked it. I hope you learned something today. If you want to see more of such videos around DEX or how to manage your roles, please let me know maybe in the chat. Let us know via Twitter or LinkedIn if you liked it. Also, the upcoming sessions around platform engineering are maybe of interest to you. In 2 weeks, I will again present. I hope you like the presentation. So maybe we see each other in 2 weeks again about platform engineering with Backstage, getting started. And later on, we will see day 2 operations with Cosmotron and Cluster API, how to manage the cluster lifecycle of your clusters. Also pretty interesting talk by my colleague, Julian Hennig. So yeah, sign up for the talks. We promote them on LinkedIn. Thanks for joining today. And yeah, have a great rest of your day. Bye, everyone.